can't give those to students. I understand something's in pain, which is why you asked the question. However. Okay, guys, we're starting off easy. We're in chapter 4, section 1. Easy stuff. We're first of all defining a polynomial in one variable. A polynomial in one term or one variable is a collection of two or more monomials and is of the form a sub naught x to the n plus a sub 1 x to the n minus 1 plus a sub 2 x to the n minus 3 plus ... all the way to a sub n with no x. Let her do her thing.
She's not giving me the highlighter. I don't have a highlighter.
It's in your lap. Come on. We're going to start this off with Sada, Destiny. Remember, I got to call you guys out now more often. So in this case, a sub naught cannot equal 0. If a sub naught equals 0, then I don't have a first term, and whatever the second term is becomes the first term, right? So obviously at some point, I have to have some terms. So a sub naught's going to be 0 because it needs to be whatever my first term is, and is always a non-negative integer. N is always, sorry, N. I didn't say the whole sentence. N is always a non-negative integer. What is N? What am I talking about when I say that, looking at that equation, guys? The exponent. The exponent is a non-negative integer. The coefficients can be anything. Yay! Exclamation mark and all. The degree of a polynomial in one variable is always the highest exponent on one term of the polynomial. The leading coefficient of a polynomial is the coefficient attached to that highest degree. For example, state the degree and the leading coefficient of 5m squared plus 8m to the 5th minus 2. So we want the degree. I can spell. Degree. What is the degree of that? That is the highest exponent, Tamaya. 5. Not even with the question mark. The degree is 5. That's the highest. Oh, yes. Easy stuff. We've done this before. That's why today's starting off easy. Okay? And then we've got, what is the leading coefficient? It is 8. The leading coefficient is the coefficient. It's the coefficient on the highest degree. The coefficient that's attached to the highest degree. The highest degree was 5. What's the coefficient of that one? 8. Doesn't need to be the one in front, even though if we were asked to put it in order.
What if I were to be like the highest?
They can't hear you. Sada. You want me to stand over here? Well, I'm saying Sada, not Sarah. Sarah. So, any questions there? Sada, you don't have a question? Okay. How about you, Storm? No? All right. By the way, I'm sorry. I know your dad emailed me Sunday night, and I'm like, yeah, I'm not working on those right now. Yeah. Okay. Determining the roots. Roots, guys, there are a bunch of words that are thrown around semi-interchangeably in mathematics. One of those words is roots. We know that the roots of a polynomial are the locations that the polynomial intersects the x-axis. In other words, we set the polynomial equal to 0 and solve. So first example here, state the number of roots and determine the roots of the polynomial and graph it. X squared minus 6x plus 9 equals 0. So it's already set equal to 0. Now we're going to solve for x. We need to bring in our factoring skills that we should have from last year. Factoring skills. X minus 3 times x minus 3. Or you could say, as Albert said, x minus 3 squared. As long as you understand that, that's fine. But x minus 3 times x minus 3 equals 0. Bless you. So therefore, we have our two parentheses. Each one gets set equal to 0, even though this is a multiplicity too. In other words, this happens twice. It's not going to return something different, but just so we have the pattern down, I can set each one equal to 0. The fact that it happens twice, later on we'll call that multiplicity 2, but right now we're just going to say, how many roots does it have? 1, and that root is 3. But number of roots, we're not going to say 1. It's always going to be that highest power. 2. And because you guys are pre-calc, I'm going to go ahead and say we are going to bring in that word. I changed my mind in 5 minutes. Haha. Actually, it was like 45 seconds. Mm-hmm. So, the degree, so, Tylee, the highest degree of a polynomial also determines how many roots there are to the polynomial. They are going to be the same number. The highest degree of a polynomial determines how many roots there are.
So in our first equation, when we had the 5 degrees, there would also be 5 roots?
There would be 5 roots.
Okay.
The fundamental theorem of algebra, which I don't know if it's I put this in the notes. I did not. The fundamental theorem of algebra states that any polynomial will have as many complex roots as the highest degree, as the highest power in it. Okay? Fundamental theorem of algebra states that whatever the highest power is, that is how many complex roots we'll have. What is a complex number? It's always in the form of what? That's a rational number. Anybody remember? You should know complex numbers, Emil. We just learned about them. What's the form of a complex number? The form. I want you to think about your circuits. Nope. Complex numbers are always the form of a plus or minus bi, because complex numbers have a real part and a imaginary part to them. Real parts and imaginary parts. So in other words, we can have imaginary roots, right? We can have imaginary roots. So are we okay that the number of roots are 2 because of the fact that the highest exponent is 2? We good there? Okay, and the root itself is 3. Multiplicity 2 because it happened twice. Okay? Now let's graph it. Okay, this only hits the x-axis once. At what number? 3. And is a positive x squared, so which way does the parabola face? Up. So, we do our best. We do our best sketch. I gotta say, that was a really good sketch. So, I picked 9. Why do you guys think I picked 9? Yeah, if I plug in 0 here, I get 0 minus 0 plus 9. So I get the coordinate 0, 9. That's why I use that one. No, I know, it does higher. You could make a quick XY chart if you wanted to, but this is just a quick sketch anyways. Because if I go to plug in, what do I get when I plug in 1 or something like that? I'm going to find out that my graph isn't as good as I thought it was, and then I'll be sad. I don't want to do that. Yes? A plus BI. plus or minus. Because imaginary roots always what? Do you know? Can you think? What do you think? How do you get an imaginary number? Negative square root. What's always in front of square root? Plus or minus. So imaginary roots always come in pairs. Okay. All right, the next one's an example to try to get us a bit more onto how to factor. So we're going to do it again. So Mr. Tiley, who's got a black eye, he's trying to hide with his sunglasses. No. Okay. I know I punched him later. After you looked at him, I punched him. Tiley, how many roots does this have? 3. Now, I need to give myself some room here because we need to find those roots. Here was an issue. Oh my gosh. I think 100% missed question. 100% by the class missed question on the last chapter 3 test. I gave you guys a rational function, and the denominator was x cubed minus x squared. And I don't believe one of you guys factored that right. So, yep, you did. Okay. All right. So, guys, if I want to factor this, first thing I need to look for is there something I can pull out of every single term? X. And really quick on your, this is a pencils down, eyes up moment, except for my 2 working on Chromebooks. They're fine to keep going. The denominator was this in your test, x cubed minus x squared. What can I pull out of both of those? X squared. What would be left in the first one? And that? 1. That's how the denominator factored. I saw all sorts of stuff. Made me question reality. I didn't know what was going on. So, anyhow, same concepts going on right here. Factor an x out. And Sarah, what would I get when I factor x out of each term? What would I get in the first one? X squared. Sarah, go on. Plus? No, remember when you're factoring, you're dividing it out. So if I take an x, if I divide an x out of 2x squared, what would be left? Okay, and what else would be there? No. Sara? Yes. 2. Okay. 2x squared divided out by x, you lose one of the exponents, okay? And then, Sarah, if I divide negative 8x by x, what would be left? Negative 8x divided by x, I get what? Just 8. You're canceling that x out, Sarah. Okay. Now I need to factor this. Hopefully, I'm just going to make an assumption really quick that it factors into 2 binomials. So, adds to 2, multiplies to negative 8. Adds to 2, multiplies to negative 8. Emil, what does that factor into? This trinomial factors into what times what? Don't recall? Hey, let me let Tylee give it a shot. And if not, then Amaya. And if not, then Indigo. X minus 2, x plus 4 will work. Okay? Negative 2 times 4 makes my negative 8. And negative 2 plus 4 gives me my middle term of positive 2. That is it. So now I get my 3 roots. X equals 0. Because that's this x right here. X minus 2 equals 0. And x plus 4 equals 0. x equals 2, and x equals negative 4. These are sketches. Throughout this chapter in particular, we're going to learn how to build our sketch so that way it's more and more accurate without ever having to create an XY chart. Our goal is no XY chart. That is the goal. Right now, this is going to be a quick and dirty sketch. How you doing, Victoria? Feel very peaceful? I don't know, it's throwing me off because you got like the black peace sign with like the dark hair and like the black blouse. I'm feeling a lot of dark hippie from you right here. Oh, wait, there it goes. Never mind. Happiness restored. It is warm in here. Oh, I've got it on warm. That was like back from Saturday. Okay. All right. Okay. Sketching. We crossed the x-axis 3 times. -4. Careful. Okay. 0 to -4. Now we need to bring in something from last chapter in order to graph this completely. Okay. What, Amaya? What does that mean? It's what an x cubed looks like. So we're talking what? You did it in one of your questions on your test. N behavior. Okay. N behavior. Is this a positive or negative x cubed? Positive x cubed. Positive x cubed, guys, this was literally a question on your test. A positive x cubed starts low, ends high. A positive x cubed starts low and ends high. So I know I've got arrows, starts low, ends high, and now I just connect the dots. This is just a quick sketch. You know, I'm going to have to post this on YouTube. I'm going to have people like commenting. They're like, actually the maximum is, and I really don't care because I'm just making a quick sketch. Actually, the maximum goes from here and here. There you go. You're welcome. You could have just played it back later. Maya? What did I just say? This is a quick sketch. This is a quick sketch, so I don't know. Amaya's correct. Pencils down, eyes up really quick. Okay? I don't know that it doesn't do this. Can't even do that. You know, I don't know. Sure. Could it look like that? Sure. So, but later on, we're going to find out how to pinpoint where those maximums and minimums occur, and we'll be able to get those down. Okay? Since it's a positive odds. If it was a positive even, it's like this. Positive odd. Okay. Huh? Right. Yeah, you guys get to see more and more why I need that webcam installed because I'm just like, positive evens, positive odds. I mean, whatever. So. Okay. Let's go backwards. Oh. The monster in my AC unit didn't like me saying that. Okay. If we know the roots, we can build the function. We all right, guys? If we know the roots, we can build the function. Correct. So Jada's already building it for me. Okay. So we're on page 2, middle of the page. Write a polynomial equation.
What was the number of roots and roots?
Number of roots was 3. The roots were. Right. I apologize, Sada. Roots are here, here, here. I apologize. Okay. So now building the polynomial. If we have this, Jada already started us off. So this is a positive 5. So it would have been built from an x. Well, actually, let's do the full steps. So we know one of our roots we actually say is x equals 5. X equals negative 2. X equals 3. This is if I were to show every single step. They gave me my roots. I set x equal to each one. Now, what do I want each one of those actually to be equal to? 0. If we look back, the step right before this was they were equal to 0. So, x minus 5 equals 0. X plus 2 equals 0. X minus 3 equals 0. So if each one could be equal to 0, then their product now we get to the step that Jada had skipped to. Jada skipped right to there because she's a brilliant young woman. And Jada said we'd have that. But that is not the polynomial of least degree yet. Now we've got to distribute all over the place. Yes? It would be. Thank you, Victoria. No. Sounded like Estrada when he mimics kids. You just don't have a good relationship with him, do you, Tyler? So, I gotta watch what I say because now that's gonna just be posted on YouTube. All right. So, guys, take your pick, whichever ones you want to multiply first, and then you bring in the third one. Multiply 2 of them. That one. Thank you, Aiden. That one. Okay. I don't know. I'm regretting my life decisions. Okay. So, Tyrell, pick 2. Huh? Yeah, which 2 parentheses do you want to distribute first? Okay. So, Tyrell wants to distribute the first 2, x minus 5 times x plus 2. So we can do that. Now, I'm going to get into something that's awfully American of you guys, or teenage of you guys. I don't know, making assumptions about being American. But it's just about something I've noticed. I'm going to go ahead and combine my like terms in this left-hand one. Okay? When it comes to what you guys like to do, if you put the x minus 3 on the right, there's nothing wrong with that mathematically. But teenagers at your guys' level, you tend to not like to distribute the larger polynomial to the smaller one. It works just fine. But if you don't want to, then put the x minus 3 on the left. Okay? It does, yeah. You don't have to. Okay. Guys, double check my distribution. I have x cubed minus 3x squared minus 10x minus 3x squared plus 9x plus 30. Combine like terms. This will be here. Okay. Why did I do x?
Why did you distribute x minus 1?
Because they were multiplying, so I had to distribute.
Okay. Oh, okay, I see. Never mind. I
Okay.
didn't see it over there.
All right. Sorry if I didn't give you enough room. And I could have pushed enter a few more times and given you some, but oh well. So there's no particular, other than it's prettier, it's a little less combining like terms, why I put it on the left instead. So do not write this down. You guys don't have the room anyways, so pencils down, right? If I had decided instead to multiply this way, we could see, if I left it on the right-hand side, if I'd wanted to, I could have done this. Right? Combine like terms. And I get the same thing. Doesn't matter which side it's on. But when you don't have a binomial on the left, if you're an arrow drawer, I draw arrows because I teach. I don't usually draw arrows when I'm doing my own work, right? If you're somebody who likes to draw the arrows when you distribute, if you have anything larger than a binomial on the left, your arrows start running over each other. When you have the binomial on the left, goes to the top, goes to the bottom, never intersect. But here, once I started doing the 10, it starts crossing over the other lines. And that's the only reason, really, why people don't like distributing that direction. And you could also distribute from the right if you'd wanted. But so there's the polynomial of least degree. We okay with that? Cool. The next one brings in a concept that we have to remember, which is, what is I squared, Wyatt? No. -1. We have to remember that I squared is -1. So we're doing the exact same thing again. We're doing the exact same thing. Our roots are plus or minus square root 2. What's the next root, please? Plus or minus 3i. Any other roots? 1. Okay. This will be long. This will be a longer problem. But we got a full 10 minutes left of class, so we're all right. If you want to skip any of these steps, like Jada did on the last one, that's fine. I'm just showing them all. It's more like a lambda than an x. And it did, didn't it? How much room did I give for this one? Oh, the bottom of the page. Look at it. See, Indigo's like already got what I've got, and she's got it, right? Bam. Make sense so far? You good? Did you guys actually balance yourselves perfectly? Oh, no, we got... Sorry, Aaron's like, I'll take you both on. We have an odd amount of people in here, so it's impossible too. We had 2 and 2, 3 and 3, 3 and 3, 1 versus... We can't. Nope. We'll take you on. What's down Shut up. Back me up. Okay. All right. There we go. Yeah. Yeah. Come on. Let's have a math off. Let's go. Let's go. Okay. I'm just giving you guys time to write. So, obviously, I'm going to put, just like the last one, each one of these into parentheses. I'm going to stop because right here, if we bring in a key concept that has been taught, Wyatt and Tyrell, if we bring in a key concept that has been taught, our life is not going to be too difficult right now. I know that looks long, horrible, ugly, and if I distribute, it's just going to get messy all over the place. Somebody give me the magic word for these and these. There's going to be some cancellation because they are what? What kind of pairs? Marisa? No, those are irrational, but no. Okay. C. I don't know what's going on with you, Lucas, and I hope this microphone picked that up, whatever it was. Okay. Yeah, sure. Okay. You should know that. Okay. You almost said it? Was that when you were like, ah, ooh, E? Yeah. It was. I'm pretty sure. I thought you might have been. I thought you might have been like Christopher Walken trying to sing the Witch Doctor song. Ooh, E, ooh, ah, ting tang. Okay. So, guys, so Sarah was correct earlier. There are going to be some cancellation because when you multiply conjugates, what happens? What's the big thing? There's no middle term. There's no middle term, right? Don't forget. So, the thought really quick, because these are some more complicated conjugates. If we had x plus 3 times x minus 3, that ends up equaling x squared minus 9. There's no middle. There's no middle. It's just that squared minus that squared. So that's x squared minus, what's square root 2 times square root 2? 2. Okay. Amaya? Preguntas? Okay. You just square that second term. The square of square root 2. The square of square root 2 is 2. Okay. Shh. Guys, this is the last question before your turn, so let's get through it. So, here we're going to get x squared minus 9i squared. You knew you were going to get a bunch of people smacking their lips the second you said that. Okay. Right, because the mic's not picking you guys up that well. Yep. Everything. Hey, I'm uploading these videos raw. I'm not editing them. That's way too much of my time. So. Okay. Wyatt said a second ago, I squared is what? I have no idea. So, It picks you guys up a little bit, but it just sounds like murmuring in the background.
Hello.
Murmuring.
Help, he's kidnapping us.
Okay. All right, guys. At this point, there are no shortcuts. We simply have to distribute and combine like terms until we're done. I'm going to leave that x minus 1 for last for sure. And then, so I'll do these ones. Oh, wow. Nothing even combined. Okay.
Solve for X.
So, no, solving for x is where we started. Oh, it's okay. So, that's it.
Can you make an outro song for our
You guys can make an outro and intro song, and then we'll let somebody else like edit videos and like bring in the outro and intro song. Okay. But it's got to be better than the Van Normus song. So, if any of you guys follow Van Norman on YouTube, it's got to be better than his song. I heard you.